This third example, I'm going to set this one up because something's a little bit different here. So we're dividing by 10x minus 6. So in the initial start, when I'm doing this division, everything's still the same. So 10x minus 6, and we're dividing. And here's where this is a little bit sneaky. We always need placeholders. And if you think about numbers, right? Like if we're dividing like 100,001, all those zeros are basically serving as placeholders, right? They're representing that specific digit, right? If I just wrote 1 and then a bunch of space and then a 1 without the zeros in there, okay, we don't recognize what that number might be. Well, expressions need to have placeholders as well. So really what I'm getting at here, when I look at this equation, I have an x to the fourth, I have an x cubed, but there aren't any x squareds. We need x squareds in this equation, so we have to add in basically the polynomials version of a 0, okay, the placeholder. So I'm going to still have that 10x to the fourth, the minus 6x cubed, but because there aren't any x squareds in there, we're going to add in 0 x squared to serve as that placeholder. And that has to happen if you don't have that in there. You might do everything else correct, but it's not going to give you the exact quotient that we get from this division. Okay, so that's sneaky. And again, it's recognition. So from here on out, when we're dividing, we need to start with, are there any missing terms in both what we're dividing and what we're dividing by? Okay, so no x squareds, we'll add in the 0x. We have x's, so minus 30x, and then plus 18. And from here, we're good to do the division. So just like yesterday or on Wednesday, I'll go ahead and just do the first step and then let you all kind of repeat it since it's the same thing from there. And we're going to go through that with example 3, and we'll do the same thing with 4. So just as a reminder, what we're trying to accomplish with the long division is, this camera won't focus, there we go. Basically eliminating this first term. So we're thinking about 10x times what gives me 10x to the power of 4. That would be x cubed. X cubed times that 10x is going to give me this 10x to the power of 4. And thus those will subtract away and they'll basically eliminate. Now this x cubed also multiplies to the negative 6, making this negative 6 x cubed. And so we're going to subtract. And by subtracting, come on, camera. (10x to the fourth minus 10x to the fourth, those cancel. Negative 6x cubed minus another 6x cubed, those cancel, and we get 0. And those would be 0x cubes. Man. Okay, so this is another unique thing in that we're getting this 0x cubed here. And so when we think about what happens next, if we keep things the same, we would technically, and I'm sorry, I'm just going to roll with this one and do this one all together because this is a little odd. But let's just kind of keep things consistent. Let's bring down this next term, 0x squared. And let's just pretend that we do everything the same, okay, and not let the zeros throw us off. So for me to get another 0x cubed, I need to add in or multiply this by 0x squared. So 0x squared times 10x gives me 0x cubed. And then 0x cubed minus 6, or times negative 6, is also 0x squared. So basically all of that isn't going to get us much. And technically we could have skipped that, but this is just me kind of keeping it consistent. So all these go away again, and we're left with 0x squared minus 30x. And just like before, or all the other steps, we're going to keep things the exact same here. So now we need to think about what do we need to multiply to get this 0x squared. I'm going to multiply this by 0x. So 0x times 10x is 0x squared. 0x times negative 6 is 0x. And now when I subtract these, all that's left over is negative 30x. and then plus 18. Okay, so we basically could have skipped all these zeros and just gone to that negative 30x. But again, keeping it consistent, and that way we're doing the same thing every time and not letting those zeros throw us off, probably a good idea. And now the last thing that we need to do is eliminate the negative 30x by multiplying this whole expression by negative 3. So negative 3 times 10x is negative 30x. Negative 3 times negative 6 is positive 18. And after subtracting these terms away, sure enough, we get a remainder of 0. And so just stating the result of our division, we would not need to include these 0x squareds and 0x's, right? Those are basically those placeholders. So our division here, and if we're kind of tying it back to the whole purpose of why we do the division, right? That's the factor. We would say that 10x to the fourth minus 6x cubed minus 30x plus 18 is equal to 10x minus 6 times x cubed minus 3. And we could work on getting solutions from there. And that x cubed minus 3, getting solutions from that is not very easy because that is not a difference of cubes. It's close, but it's not quite there. Okay. So again, with that remainder of 0, that confirms that this is a factor. And we like that. We would then be able to work on finding solutions after that if we needed to continue with that work there. All right, so let's set up number 4, and then I do want you all to work through this one. Number 4 brings in another kind of weird or sneaky part that we have to add into this procedure here, because now if you look at what we're dividing x to the fourth plus 7x squared plus 10. There's no x cubes, there's no x's, so we need placeholders there. In what we're dividing by, x squared plus 2, same idea. There's no x's, so we need to add in a placeholder for that term as well. So when we set this up, we need a bunch of placeholders for both what we're dividing by and what we're dividing. So this is x squared plus 0x plus 2, and we're dividing x to the fourth plus 0x cubed plus 7x squared plus 0x plus 10. All right, why don't you all take it from there? Carry out the division. Do the best that you can. Check with your group. I'm going to stay consistent with... Okay. So you should have got a remainder of 0 here, telling us that x squared plus 2 is a factor. With the 3 terms, when you first take this x squared, it needs to multiply to all 3 terms. Okay, so I'm doing x squared times x squared to get x to the fourth. I'm doing x squared times 0x to get 0x cubed. X squared times 2 to get 2x squared. Okay, so that third term doesn't change anything. We just got more to multiply and then more to subtract with each step that we do here. Okay, again, don't let the zeros kind of throw you off. Just keep it consistent. Okay, and then we keep going all the way until we get to the last term, that 10. When I bring that down, I got to multiply this entire expression by 5, and everything subtracts away from there, giving me that remainder of 0. And then again, what we've just accomplished, we've taken this x to the fourth plus 7x squared plus 10, and we've now factored it. X squared plus 0x plus 2 simplifies to just x squared plus 2. And then our quotient, the result of the division problem, is x squared plus 5. Did we need long division to factor these? Why not? What else could we have done here? Or what else is a factor like? Somebody help me out. What's this factor like? Yes, how do you know, Grace? Yeah, but in this equation, before I even start with that, what's the exponent ratio there? What's 4 divided by 2? 2. So we get the 2-to-1 ratio just like a quadratic. So this factors the exact same as x squared plus 7x plus 10. I did not need long division to do this factoring. We had a method that already factored this way. Okay, that's one of those factoring patterns that we had worked on a couple weeks ago, or I guess last week probably. But nonetheless, long division accomplishes the exact same thing. All right, so long division, really the only time, especially in this class, that you would need to do long division is if we're dividing by a polynomial that is not linear, right? So this x squared, so since we're divided by x squared plus 2, we would have to do long division here if we didn't recognize that it factors. Okay, but what I'm about to transition to, we're going to start dividing by linear factors, and it's a much quicker process. Okay, so as we're going to work on both. You're going to have a homework assignment where you are going to do long division and this next method. But basically, once we move on from this lesson, we're going to be doing this new method a lot more frequently. Okay, so the last thing that I'll mention here is that if you have to do any sort of division, the only reason that you should resort to long division is if you're dividing by like something that's x squared or something that's x cubed or something that's x to the fourth. But if you're dividing by a linear expression, so like 10x plus 1 or x minus 4, then this other method is going to be much more efficient and much easier for us to work through. So let's look at that other method and do that right now. But actually, before we do that, let's actually have us do the long division method with this as one more practice problem. And then we'll do the new method right next to it, and we'll just kind of compare them. Okay, so why don't you all just do this division with the long division, x plus 3 divided, or excuse me, x cubed minus 2x squared minus 9x plus 18 divided by x plus 3. Do that underneath this long division. I'll do the same. And then we'll do this synthetic division right next to it. Synthetic division being that new method that I'm referring to. Okay, again, take a few minutes. I just need you to try. Please don't sit there and do nothing. So this division should have been a little more straightforward. We had no missing terms, so we didn't need to add in any placeholders here. And we only have to multiply 3 different terms. And once again, we get a remainder of 0. Okay, once again, confirming that x plus 3 is a factor of x cubed minus 2x squared minus 9x plus 18. So give us a sec to get this all written down. And with this, are there any questions with where any of these values are coming from? Because now we're about to do that new method. All right. So again, if this was on a homework assignment and it said divide these polynomials, you could absolutely do the long division, but because we're dividing by a linear term, x plus 3, I know it's linear because the exponent is just a 1, right? If it's an exponent of 2, it's a quadratic, exponent of 3, cubic. We would have to do long division. But with that linear divisor, we can use what's called synthetic division. Okay, and this is where I need your absolute attention here because all next week we're going to be doing synthetic division probably every single day. Okay, and it's a fairly straightforward process. It's much less complicated than this long division. Okay, and there's a lot less writing to do here. So, a couple kind of introductory things with long division or with synthetic division. The way that we set up synthetic division, we have this kind of half box, and I call that the chair. Okay, inside the chair, we're going to take what we're dividing by, in this case, x plus 3, and we're going to set that equal to 0. Now, when I take a factor, and we've already confirmed that this is a factor, because I got a remainder of 0. When we take factors equal to 0, and I get x equals -3, what do we call this -3? What is that referring to? This polynomial is what? Come on, let's not stare at me all period long. Somebody help me out. Gara, I see you're looking, you're itching to say something. Help me out, please. What is that? Yes, an x-intercept. What's another name for an x-intercept? Your quiz yesterday, problems 1 and 2. What'd you have to solve for? The equation's what? Zeros. What's another name for those zeros? Solutions. Okay, there we go. A few more voices. Much better than you all just staring at me. Thank you. Okay, so what we are using in synthetic division is what we think is a solution, or what we think is a zero. So in the chair, we take that factor, we set it equal to 0, and we put what we think might be a solution. Okay, so we have to do a little bit of work before we even jump into the division here. So again, basically what we're doing is we're asking ourselves, is -3 a solution to this given polynomial? We already know that the answer is going to be yes, because we got this remainder of 0, and we knew that x plus 3 is a factor. Okay, so first part of it. The next thing that we're going to do is we're going to take all the coefficients from this polynomial, and we're going to write them next to the chair. Okay, we're going to give ourselves some space. So 1, a -2, a -9, and an 18. All those numbers are the coefficients of the polynomial for what we're dividing. And then we're going to give a little bit of space, and we're going to put an addition bar. And that's another nice thing about synthetic division. We're not subtracting. Whenever we subtract, it's easy to make mistakes. So the fact that we're adding here makes it a little bit more straightforward. All right, so here's how this process goes. Every single time, you take this first number after the chair and you just bring it down. We don't do anything to it. Then we're going to take this number that we just brought down and we're going to multiply it by the number in the chair. And we're going to place it underneath the next coefficient. So I'm multiplying 1 times -3 to get -3. So 1 times -3 gives me this -3. And then we add these two numbers. So -2 minus 3 is -5. Do we see a -5 somewhere in our quotient for the long division? Yes, that's referring to that same -5 there. This 1 is referring to that 1 in front of the x squared. Then we do the exact same thing. We take this number underneath our addition bar and we multiply it by -3. -5 times -3 is 15. And then we add -9 plus 15 is 6. Do we see a 6 somewhere in our quotient from the long division? It is that same 6 right there. And then we got to do this one last time. We take 6, multiply it by -3, and get -18. And we add and get 0. That 0 is referring to our remainder. So there's a lot of similarities, okay? And that's why we have these, why I wanted us to put these next to each other, so we can kind of see where these results of our synthetic division show up in the long division. Okay, so here are just some things to kind of help with what we do from here. Okay, because a lot of students can carry out this synthetic division, right? It's just adding and multiplying, right? We're not doing anything crazy math-wise. This last number is always our remainder, and I'll put this dashed line just to kind of remind myself that that is the remainder. From here, we need to interpret what these values are. And what I'll do is I'll always interpret it going right to left, because I know that the rightmost number is my remainder. The next rightmost number is our constant term. Constant term referring to the term without any variables. So that's that same 6 that we got from when we did the long division. And then after that, this is our linear term. Linear term having just an x. So that is referring to this negative 5x that we got from doing the long division. And then the next term would be our quadratic, which is x squared. So these numbers, they are the coefficients to the quotient of our division, and we just need to piece this all together and write the actual expression. So this is a 1x squared, a minus 5x, and then plus 6. And that is the result of our division. And that's the same x squared minus 5x plus 6. Okay, so the interpretation is another place where students will get confused on. And again, if you just go right to left, it goes remainder, no x, then x squared, then x cubed, x to the fourth. It follows that same pattern every time. Isn't it so much nicer than doing all that subtraction and writing all those x's and x squareds? Okay, and once you get the hang of this, we're going to be doing it very quickly. Okay, and that's what we're going to work on the rest of the period, is getting a little more familiar with this. So now, in order to use synthetic division, you must take the coefficients from each term of the polynomial. Okay, coefficients being those numbers in front of all those terms. That's referring to the 1, -2, -9, and 18 that we placed up there. Just like with long division, if we skip any terms, we need to add in placeholders for those terms. So if there's any missing terms, we'll add in zeros there. And we are going to have some that have missing terms. All right, so let's do number 6 together, just to make sure we have this process down. And then I'll have you all do 7, and we're going to do, oh, my numbering is off. Let's call this 8. We'll do 8 together, because 8, we're going to be dividing by fraction. Yes, you are going to work with fractions here. So we're going to learn a little bit better on how to work with those fractions. Process won't change. Okay. So we need to do this division. Again, let's pretend that it doesn't specify to use synthetic division. What allows us to use that synthetic division is that we're dividing by a linear expression. Again, if that was like x squared plus 3, this doesn't work, right? So the first thing we do is we take what we're dividing by, we set it equal to 0, and we figure out what is the potential solution. And I say potential solution because we don't know if that's a solution yet. It all depends on what we get for our remainder. So I'm going to place that potential solution in the chair and then bring down all the coefficients from the polynomial for what we're dividing. So that being 1, -2, 1, and -6. And now we have our addition bar. And the first thing we do is bring down this 1. Again, that stays the same 100% of the time. You will never start any different way. You always bring down that first coefficient. Then we'll take this number and multiply it by the number in the chair. So 1 times -3 is -3. Then we add -2 minus 3 is -5. And then I'm going to do the same thing, -5 times the number in the chair, which is 15. Add those together to get 16. And then take that number, multiply by the number in the chair, 16 times -3. And that would be -48, I think. And when we add these last two terms together, we get -54. Now again, interpreting these values, just as important as the procedure. -54 is that remainder. 16 would be the constant term. -5 would be the linear term. And 1 would be the quadratic term. So the result of our division, I don't have a ton of space for this, I'll write it up here, is 1x squared minus 5x plus 16 plus the remainder of negative 54 divided by our original term that we are dividing by. Okay. Anytime we have a remainder, for us to write the correct quotient, we still use that remainder and just say that that remainder is still getting divided by x plus 3. But again, this doesn't do much for us. If we get a remainder of non-zero, it's kind of irrelevant. Okay, everyone try number 7. Be careful because there is a missing term in what you're dividing by, right? There's a fourth, a cubed, a squared, but there's no linear term. So you need to add in a 0 where that linear term would be. All right, take about 3 minutes, work out number 7. Save number 8 because that one's going to get a little tricky. We're going to have to work with a bunch of fractions there. And timing-wise, we should be perfect to get done with this right at the end of class. So be careful because, again, if you don't have that placeholder in for where that linear term is, you're going to get a completely different remainder and thus reach a different conclusion for whether or not n minus 2 is a factor of this polynomial. And the values that you should have gotten go 1, 3, 1, 2, 0. Now again, the interpretation for what these values are, right? If we can do the synthetic division and get these numbers, that's great. But if we don't know what those numbers mean, then it doesn't really matter, right? So we have to understand what these values actually mean. The last number is always your remainder. Okay, so that's why I add in that dashed line just to separate it. You don't need to add that in, but it is just a reminder for my brain to say, hey, that last number is the remainder. 2 would be the constant term. 1 would be the linear term with an x. 3 would be the quadratic term with an x squared. 1 would be the cubic term with an x cubed. So the result of our division, okay, and again confirming, I guess not x's, but n's here, we are saying that this polynomial that we started with and divided, we get n minus 2 times n cubed plus 3n squared plus 1n plus 2. And now we can work on finding all our other solutions. So not only did we confirm that n minus 2 is a factor, we also confirmed that 2 is a 0 or a solution or an x-intercept. Yeah, all those things that you all had mentioned earlier. And again, this is what we're going to be using all of next week. We're going to do this a lot more. All right. Well, we've got one more. And with this last problem, we do have, we're going to get a fraction. So we're going to have to do some fraction math here. Don't worry because it usually works out really nicely. And if you're like, you know what, no matter what you tell me, I can't do work with fractions, you can always use a calculator. So let's see how this works out. Again, I always start with taking what we're dividing by, in this case 8x plus 9, and set it equal to 0. Because now, for me to figure out what that potential solution would be, I have to subtract 9 and divide by 8. So we're checking, is negative 9/8 a solution? So in the chair, we're going to use negative 9/8. And then we're going to bring down all the coefficients and include the 0 where that linear term should be. So 32, 36, 0, and 10. And now we're on our way. So no matter what, bring down that first number. Don't do anything to it. Just leave it the same. Now when we multiply, okay, I need to do 32 times negative 9/8. These are going to get fairly large since we're multiplying by 32. But remember how we multiply fractions. And I'll just do this on the side to kind of show us here. But when I take negative 9/8 and I multiply it by 32, I'm first want to make 32 a fraction, so I'm going to put it over 1. And we multiply the numerators together. So negative 9 times 32. Need a calculator for that. And that's negative 288. And I multiply the bottoms together. So 8 times 1. That's 8. And then we just need to divide negative 288 by 8. And hopefully it divides out all right. Oh, thank goodness it did. Okay, we get negative 36 there. Okay, so by multiplying 32 times negative 9/8, I get negative 36. And once again, we start all over. So I add these numbers together. 36 minus 36 is 0. Well, that's nice, because now when I do 0 times that fraction, I don't need to do the fraction math. That's just going to be 0. And so when I add, I get 0 again. And then 0 again, I get a remainder of 10. Well, that was lame. I only had to multiply the fraction once. So now, interpreting this answer, says that 10 is the remainder. 0 is the constant term. Other zeros are the linear term, and 32 is the quadratic term. Now, we actually have to do one more thing to this, and it's kind of an odd reason why. I don't like the example for this, for us to do that because of all these zeros. So you know what? Let's stop right there. I will not give you the homework sheet for today, as we will work on that in class on Monday. So if you have missings, do them over the weekend. If you haven't given me the quadratic remediation work, give it to me over the weekend, or work on it over the weekend. And make sure you get all caught up. That is right. Well, sort of.